In the previous in-class lecture, we learned about quite a few of the special function registers. We learned about the ports, we learned about the tris registers, we learned about the basic architecture of the PIC that we're going to be using, which is the PIC 16F887, and we learned several different assembly programming commands. Today I want to introduce you to several more commands. This will be the first in a series of 3 videos that will introduce you to some more programming commands in assembly, and then the next video will introduce how to do if statements in assembly, and the final video for the day will introduce how to write subroutines in assembly, and we will get some practice doing both of those this week in class. So in the previous lectures we've talked a fair bit about the status register, and so I want to drill in a little bit deeper into what you can do with the status register. And in particular, we're going to pay attention to about 5 bits of the status register. We're not going to worry about bits 3, 4, or 7 at this point. Over here on the right-hand side, this is bit 0, 1, and 2. And those tell us something about what happened in either a logical operation or a mathematical operation. So if you performed a subtraction and the result went to 0, if you performed a logical ANDing or ORing and the result went to 0, the Z bit, bit 2, is going to be set. If you have a mathematical operation and there's a carry, this carry bit will respond. And you'll need to look through the data sheet to see exactly how it will respond. There's a bit of a difference in how it responds to addition versus subtraction. But if you have addition and there's an overflow, that is, the sum is bigger than 255, can't be supported by an 8-bit register, then this carry bit will be set. Borrowing will actually behave the opposite way. When you subtract and you would end up with a negative value, this carry bit will actually be set, I believe. The digit carry is very similar, but that actually happens between nibbles. So if there's a carry between the 4 bits, then this bit gets set. This is used less commonly. The C bit and the Z bit are going to be used quite a bit. The C bit is also used when we do a rotate, whether that's a rotate right or a rotate left. Bits 5 and 6 over here are extremely important in the status register. Those allow us to select banks, and as we already talked about, there are 4 banks on the PIC that we are using. Bank 0, 1, 2, and 3. And the binary value that you put in bits 6 and 5 correspond to which bank you go to. So if you put a 0 in RP1 and a 0 in RP0, that will put you into bank 0. If you put 0, 1, which we hopefully remember is binary for 1, that puts you in bank 1. If you put a 1 and a 0, binary for 2, that puts you in bank 2. And if you put a 1 and a 1, that puts you into bank 3. And if you look at the table that is from the data sheet and we saw in the previous lecture, you'll notice that certain registers are only accessible in certain banks. So for example, the tris registers here, in order to use them, you have to be in bank 1 in order to access the port registers. Other than port B, that's actually accessible in a couple places. You have to be in bank 0. You can access port B in bank 0, but it's also available in another place. But unlike those two, the status register is available in all the banks, and that's critical because no matter which bank you're in, you're going to want to be able to determine what the value of RP1 and RP0 are, and to change that so you can go to other banks. You also want to be able to use the carry bit and the Z bit for some operations depending upon what you're doing to different registers. So when we switch banks, we're going to be changing the values in bits 5 and 6. Labels and comments are really important to neatly organizing some code, and they can actually help us once we get into using Goto statements and subroutines, which we'll talk about very soon. So any line of code can have a label, and that label basically just designates what you're calling that line of code. Labels have to be a single word, so you can't have any spaces in them, and they should not start with a number. They can have numbers in them, but the first character cannot be a number. And so you can say this is the beginning of a loop, so you could call it loop. You could call your code whatever the name of the subroutine is. And so when you have a goto statement, which we'll talk about in an upcoming slide, you can say go to this line of code and it automatically branches off to that line of code. We'll talk about that on the next slide. And so any text appearing after a semicolon is considered a comment. So in MATLAB you use the % symbol to indicate a comment. That's one of the things that's kind of weird about programming, is there's not a standardized way to indicate comments in code. So in this programming language, in assembly, we use the semicolon. You might remember the semicolon in MATLAB was used just to suppress the output from a command. That is not the case here in assembly. So anything after a semicolon is a comment. That's useful for annotating your code, just describing what certain lines of code are doing. That's also useful if you want to take out certain lines of code and not execute them at the moment. So if you're testing out a long block of code and it's not working, if you want to just do some iterative testing and check to see if a few lines of that code work, you can comment out the other lines just by putting a semicolon in front of those lines on the left side. So that's how you do comments in there, and it's a very good programming practice to document all of your code. Hopefully you picked that up in your intro programming class in 2050. Let's talk about these goto statements. We just mentioned them there. So up until this point, we've been talking about commands executing one line after the other in order. And that's typically what does happen. But sometimes you want to branch off to some other lines of code. So for example, if you had an if statement, you might skip over what the code is after the if statement if that if happens to not be true. Whatever condition you have in your if is not true, you're going to want to skip over the next lines of code. Likewise, if the if was true and you had an else statement, you might want to skip over whatever the else commands were. And so with gotos, we can actually skip around and not flow from one line to the next. And you can do that several different ways. The first way is to go to a label. In this case, I just used the label my label. That can be whatever word you've chosen as your label of code, as we just talked about on the previous slide. And so whatever you have assigned that alias to, whatever line you've labeled that way, it can go to that line, and it can go down in code and it can go up in code. It doesn't matter whether you're on a lower line of code or an upper line of code. It can skip down, it can skip back up. And what that does is it really just changes the program counter. So typically as you're executing code, the program counter increments by 1. So you execute the command in one memory location, then you go to the next memory location in the code block that you have, and then you execute that, and then you go to the next memory location, and the program counter typically increments by 1. Now what you're doing is you're changing the value in the program counter to whatever memory location happens to correspond to the line where you put your label. You can also go to an absolute address. So if you happen to know where a particular line of code is in memory, you can say, I want to go to the command that is in memory location 8. This is very useful if you always want to go to one particular spot, but it can be quite dangerous if you happen to edit your code and insert a line of code in the middle, and then all of a sudden all of your absolute addresses are off. So I generally recommend either relative addressing or going to a label. Relative addressing allows you to skip around a certain number of lines. So you could say go to $+4. That would skip 4 commands down on the page. So if you had a line of code and you wanted to skip over the next 3 commands and execute the 4th command after that, then you would just skip down 4 lines. If you do the same thing with go to $-3, that allows you to go back 3 commands. So it's basically just like skipping over the next commands or going back to previous commands. And you can put in whatever value you want in there after the $, positive or negative, to change direction. So why do we want to use gotos? As I just mentioned, if you have an if statement, if one thing is true, you might want to go to one place, otherwise you want to go to another place. Assembly programming does not natively support if statements. You cannot put if and a condition or else and a condition. And in the next video, and the next set of slides, we're going to talk about how to go about using if statements and developing if statements. So I hope you'll continue on to that next set of slides. We also, just as a mention to introduce one of the things we're going to talk about in that next set of slides, we're going to be using bit tests. So here are two other commands that are very useful to implementing if statements in assembly. BTFSS is short for bit test F skipping if set. So what that means is you're testing in a particular register one particular bit, and if that bit happens to be a 1 currently, what you're going to do is skip exactly one line of code and go on to the next line of code. If that particular bit happens to be a 0, you will not skip the next line and simply flow on down through. The exact opposite command of that is BTFSC, which is bit test F skipping if clear. And so what that will do, it will look for a 0 at that particular bit. If it finds a 0 at that particular bit, it'll skip one line of code. Otherwise, it will just flow right on through to the next line. So we'll see that these are very useful in the next video. So thanks for watching, and I hope you'll continue on to the next video.